Okay, this is the third session of the numerical differentiation. Straight line moving towards the problem. If the question in examination like this way, find dy by dx and d square over dx square at x equal to 54 from the following table. See, dy by dx means first derivative, d square by dx square means second derivative at the point x equal to 54 from the following table. This is the given table, given set of values. X values are 50, 51, 52, 53, 54. Corresponding values of y are like this way. These are some values given. Okay. Then for given set of values, to observe first the required derivative x equal to 54. We find x equal to 54 all at the end of the table. 54 is at the end of the table. So we have confirmed that to find f dash of 54 and f double dash of 54 or dy by dx or d square by d square, but we make use of the two formulae, number 1 and number 2, derived by the Newton-Gregory backward integration formula. These are required points. Then, for given set of values, construct the forward difference table. For given set of values, these are values of x, these are values of y, and form the difference table. You know already 3.7084 minus 3.6843 is 0.0244 and 3.7325 minus 3.7084 is 0.0241, 3.7563 minus 3.7325 is 0.0238, last 3.7798 minus 3.7563 equal to 0.00235. These are the first four differences. Then 0.0241 minus 0.0244 is the minus 0.0003 and 0.0238 minus 0.0241 is minus 0.0003. 0.0235 minus 0.0238 equal to minus 0.0003. These are second forward differences. We find that third forward differences are 0. Then write the corresponding formula to find out the derivative using the formula derived by the Newton-Gregory backward integration formula. Remember this formula directly. And dy by dx equal 1 by h into nabla yn plus 1 by 2 nabla square yn plus 1 by 3 nabla cube yn plus 1 by 4 nabla power 4 y and so on. Now in this formula, substitute the corresponding values with the help of the forward difference table. So the value of h is 1 because the difference between the conjugate arguments is 1. That is the value of h1. Nabla yn means first backward difference 0.0235 plus 1 by 2 into second backward difference or minus 0.0003. Next is 0. Then simplify this, which is 0.0232. Therefore, the value of dy by dx at x equal to 54, 0.0232. This is the first derivative. Similarly, to find second derivative, write the formula. Again, this is also formula derived by the Newton-Gregory backward integration formula. Formula is d square by d square equal to 1 by s square into nabla square yn plus nabla cube yn plus 11 by 12 nabla power 4 yn plus y by 6 nabla power 5 yn and so on. Again, substitute the values with the help of the backward difference table. H value is 1 minus nabla square by n is 0. So here we find nabla square by n is minus 0.003. Nabla cube is 0 and itself is minus 0.003. So this square by d square equal to minus 0.003. This is the value of second derivative. Hence we find out the first derivative and as well as second derivative using the formulae. These two formulae derived by the Newton-Gregory backward integration formula. Anyway, any problems are given. These are the required information. First, observe the required derivative at the end or at the beginning of the table. If it is raised at the end or almost end of the table, at the previous method to find out the first derivative as well as second derivative in case of the numerical method.